Hello everyone. I discussed with many friends about regarding their interview process. Most of the students, most of the friends are telling about the register storage class. Most of the interviewer are asking questions on the register storage class. I am intentionally making this video because every students know about register variables, regarding the scope of that variable, regarding the lifetime of that variable, and the by default value of the variable. But the problem is that about where the memory will allocate for the register variable. Everyone blindly saying for the register variable the memory will allocate inside the CPU register. Yeah, exactly, but not 100% sure. By simply writing the register int I, the compiler will not give a surety the memory is allocated inside the CPU register. No, there is two possibilities. There are two possibilities. Either this variable will allocate inside the CPU register or inside the stack sections. There is some certain conditions are there, certain parameters are there. By checking that parameter, the compiler will take decisions where should allocate the memory for this variable. So don't blindly say the register variable memory will allocate inside the CPU register. No, there is certain conditions the compiler will decide in which basis the compiler is deciding where to allocate the memory for this variable. Yeah, I will tell. The first parameter is that whether the CPU registers are available or not. First, compiler will check whether the CPU registers are available or not. Second possibility, if I allocate memory for this variable inside the CPU register, whether my execution speed of the program will increase or not. Certain conditions, based on these conditions, the compiler will take decisions. The compiler responsibility is not only to create an executable file but also to create efficient and faster program. That's why compiler will check such things. Why the compiler is not giving a surety for this variable the memory will allocate inside the CPU register? Because the size of CPU register is very small, very less. I will show the memory hierarchy. Let's see. This is the memory hierarchy. This is our CPU register. This is the cache memory. This is the primary memory. This is the secondary memory. The size of CPU register is very small. The size of CPU register is very less as compared to the remaining memory. But the fetching the data from CPU register is very fast as compared to the remaining memory. That's why the compiler first check whether the registers are available or not. Second question is that how the speed of execution is increasing when the memory will allocate inside the CPU register. How the speed of execution is increasing when the memory will allocate inside the CPU register. Yes, I will tell how the program. Suppose my program is something is there. Suppose my program is something. Here it is the RAM. The program is loaded inside the RAM. There is some registers, here some memories are there, stack section, data sections. This is for the code. And this is the CPU, or you can say processor. Inside this one is instruction register, decoding unit, some registers there, one ALU is there, some CPU registers are there. This is a RAM. In this RAM, my code is available. Some memories are there, stack, data, code sections. This is the CPU, also called as processor. In the CPU, some instruction registers, some decoding units, ALU, and different things, different registers are there. So whenever processors start to executions, first it will fetch the instruction from the RAM and it will store inside the instruction register. Suppose my instruction is integer x, my instruction is integer I is equal to 10, I plus plus, I plus plus, I plus plus. This is the I, the value is 10. Suppose I plus plus, I plus plus, I plus plus. Suppose my program is integer I is equal to 10, I plus plus, I plus plus, I plus plus. Okay, means the integer I is equal to 10 is available, then different. Okay, whenever the processor will fetch the I plus plus and put inside the instruction register, after the decoding unit, the processor will understand that is the content of I should increment by 1. But here the value of I is not available. That's why again the processor will go again the check the value of the I, then it will put then it will take inside the CPU register, then it will do the operations using the arithmetical logical unit. After the process, then again it will store inside that variable. If again I plus plus, again it has to fetch, again it has to store, again it has to fetch, again it has to store. That's why unnecessarily I'm wasting the fetching time. Here the fetching time is increasing. If I increase these instructions, the fetching time is going to increase. If I want to reduce this fetching time, so instead of allocating memory inside the stack sections, if I will allocate inside the CPU register, instead of allocating memory inside the stack section, if I allocate the memory inside the CPU register, this fetching time will decrease tremendously. That's why the program executions will become faster. So we should go for the CPU register. Here simply register int I, that is the I will allocate inside this variable. If the variable is available inside the CPU register, then this fetching time will reduce. Once it will fetch the instructions, the remaining will process done by here only. Now, I will show where the programmer should go for the register variable. Suppose this is the main integer x for x is equal to 0, x is less than 100, and x print f percentage d x. In this case, instead of in this program, we are incrementing the value of x 100 times. So in previously we have seen some diagrammatical representation of how the program is executing. In this program, I am using the value of x 100 times. I am increasing the value of x. That's why if I will allocate inside the stack sections, the fetching time will increase. That's why it will affect on the performance. So instead of simply writing int x, if I will use the register, I will remove register int x. In this time, The compiler will check, here I am using the 100 times, that's why compiler may allocate this variable inside the CPU register. That's why the speed of execution of this program will increase. So in such a case we should go for register variable. I hope guys you got the concept of this register variable and the remaining, the scope of the variable, the lifetime of that variable, the by default value of the variable is similar to the active variable. Thank you.